Hello guys, in this video we'll talk about one of the most used creational design patterns, which is the singleton. For those of you who don't know it, a singleton is a representation of a singular instance of a class across an application. It's something like the calendar, for those of you who have used it before, but in a more practical context, it's used in database connection. For example, if you want to open a connection to a database and you want that connection to be unique so that you don't open a lot of connections and keep your application optimized, you use a singleton to connect to the database and use that connection to perform other operations. So there are a lot of ways that you can create your singleton. There is the lazy initialization approach, the eager approach, and the initialization on demand approach. We'll see all these methods in this video, and we'll talk about what is the positive sides of each one, which is what is the negative side, and how to resolve the issues and which one to use in each context. So let's get right into the video. So starting with the lazy initialization, in my IDE I have a singleton class and I have a main to test everything. Let's start first by blocking the constructor and making it private so that nobody creates the instance outside of singleton class. And then we are going to create an instance variable, so private static singleton. It's static because it has to be accessed outside of the class. We don't need an instance because that's the point. So then let's create a getter, and before returning the result we'll check if the singleton is not null. So if it's null we'll have to initialize it. So singleton equals to new singleton. For better understanding, let's change it to instance. Alright, now we have our get instance, and we're good to go. In our main, let's run a print singleton.getInstance. Let's print it multiple times to see if that's the result that we have been expected. So yeah, that's the actual expected results. We have a single instance across our application, but that's not really it, because most applications are multi-threaded, and in this test it's a single thread that is running the calls. If we have an actual application that is going to perform some operations, the operations could take some time. So if you have threads, there is a chance that some or multiple threads will create new instances. And to be able to see this in motion, I'm going to add a new method. So here, public static void wait time, and here thread.sleep, and I'm gonna call sleep for let's do 1 second for now. Add a try catch, and in my get instance, before creating the instance, I'm gonna call the wait. So in here I'm gonna call main.waitTime, and inside my main too I'm gonna create some threads. So public static thread create thread, and here return new thread, and inside for the runnable I'm gonna do the same singleton.getInstance, and let's call it here create thread dot start. Alright, so now we should be able to view the actual issue in here, and you can see that some threads, or even all the threads, can be able to create their own instance. This is actually problematic, and it has to be resolved. Our singleton has to be unique. It has to be thread safe. So to be able to resolve this issue, I'm going to create another class. I'm gonna duplicate this, so thread safe singleton, and we're going to have to play with the method here to make it to block the threads so that only one thread can perform the operations at a time. So here I'm going to add a keyword called synchronized, and this way we will be able to call this method, and the threads can only run this operation once at a time. So if we go to our main, and let's call the thread save singleton in here again, instead of instead of the old thread, let's run it. And you can see that we actually solved the issue. You can see that all the threads are getting access to the same instance. The first one creates the instance, and the others access the instance that was created by the thread. So at some point you can say that it's working, but it's not really optimized, because let's say you have some operations to perform before you return the instance. The threads will be delayed. So in this context, if we do this, so we wait for the creation and then we wait before printing the results when we run our code, you can see that the threads take time to print out the results one after the other, and each thread has to go through these steps. Mainly the second thread and above, they have to wait 2 seconds before printing out the results, which is kind of complex if the operations performed before returning the result are not essential to the result. So for example, if they don't change the state of the instance variable, or they don't change something that is very essential to the actual operation that you are intending to have, it's not really important to have to synchronize the whole method for that. So if it's not really important, the best way is to synchronize only the block that is of risk, which is the block that would create the instance right here. So let's improve this, and I'm gonna add optimized, and basically I'm going to remove the synchronized part from here and add it here. So synchronized thread save singleton dot class, and then like this. So in this case, if our threads are trying to call this method, they are going to be blocked here, so that only one thread can call this block at a time. But this is not really it, because if all the threads are blocked here, let's say you have 2 or 3 threads that are blocked at this point, the first one, when they enter, they will set the instance and they will use it. The second one will set a new instance because they are all sure that the instance is null. So to avoid having the same issue, we'll have to add another check inside here. This way, the first thread, when they initialize this instance, the second and above threads would ignore this, because this condition will no longer be valid. Now if we go and copy this to our main to run it, you'll see there's a significant change, because all the threads are waiting 2 seconds and all the threads are returning the results. This way you are sure that the synchronization only blocks access to the element that is of risk, which is the creation of the instance itself. So that's it for the thread save singleton. Now let's try to focus on the initialization on demand approach. This approach is a little bit tricky because it uses the lazy initialization, but in a smart way. Let's create a class for the on demand singleton, and right here I'm going to have my private constructor. So private, and I'm going to have an inner class. I'll explain that to you in a bit. So private static class singleton holder, and here private static final on demand singleton instance equals to new on-demand singleton, and here I'm going to have to call a getter, so public static on-demand singleton get instance, here return the singleton holder dot instance. So basically what we are doing here is we are delegating the synchronization to Java itself, and by calling the on-demand holder, Java performs the synchronization in a hidden way, because in here the initialization will be performed when we call getInstance. So we are still in the scope of lazy initialization, because let's say we have other operations that we need to perform. So public static, let's say load void load configuration. So in our case, if we call on-demand singleton.load configuration, we are preparing or preloading every static variable that we have. But if you see right here, we don't really have any static variable. So when the class is getting loaded, we are not loading the instance because it's inside the static class. But when we call getInstance, it's at this time where the instance is getting loaded, because when we call the singleton holder, at this stop the Java would have to create the variable and initialize it. And in this case we are sure that the instance is unique because it's static and final, and it will be loaded by the inner class itself in a synchronized manner. So this way we are using Java's synchronized loading of that instance and still performing the operation in a lazy way. That's it for this part. If we want to move on to the next one, which is the eager initialization of our singleton. So let's create a new class, eager singleton. Basically, the eager singleton is just the inner class of this on-demand singleton. So here we have the same thing. Let's copy that and paste it here. That's the variable we need, and we'll also need the getInstance, public static eager singleton getInstance, and let's return instance. So basically in this context we are loading the instance the second we are loading the class. So in this example, if we have a variable that is called load configuration, and in our application we load the configuration first to prepare for the application startup, and then we call the getInstance to get our instance to perform some operations with it. In this case, the actual initialization of this variable will be done as the first call of the static method. So the class will be loaded when we call load configuration. So in this case we are eager to initialize the variable. That's why it's called eager initialization, and the variable will be available to us when we call getInstance. But when we go back to the lazy initialization, the variable is only initialized when we are going to call it for the first time, and then it's going to be available. So that's the difference between eager initialization and lazy initialization. It's not always good to use eager initialization because it's going to impact your startup, the application startup time, where when loading the configuration or loading the class itself, your loading time could take a lot of time, and yeah, but at some point you have the advantage of accessing your instance at any time faster, much faster than the norm, but still your application loading time will be impacted. So depending on that, and also the fact that the object will stay in memory from the time the application is loaded, compared to a lazy load-in, that memory is going to be freed from that instance until it's needed. It's going to depend on your application's context. For example, if you're using an application that has to access the database multiple times, or like every second to perform some operations, then eager loading would be the way, so that from the moment your application starts, you are going to query your application or your database to perform the operation. But if your application does not require access to the database instantly from the startup, then a better approach would be to go with a lazy initialization. Let's try to see the difference in the startup time of the application when calling an eager approach and when calling the lazy approach. So I'm going to select the eager singleton, and I'm going to skip the on-demand singleton and use the thread-safe singleton here. So let's close the rest. Right here, I'm going to make the same wait time. So I'm going to call the wait time in the get instance before the return. And I'm going to have to call the wait time for the constructor. So here, constructor private. I'm going to call the wait time in here because it's at the time of the initialization. And yeah, it seems about right. And I have load configuration in here. I'm going to call the load configuration in my thread safe singleton as well. So now let's go to our main. Let me close these right here. And for my main, I'm going to add some prints to be able to see the actual results. So here, start in the app. And let's start with the eager load-in. So eager singleton, the load configuration. And here, app started. And here, let's add some other operations to load, to get the instance to perform some operations. I'm not going to set up the operation right now, but let's add the eager, or let's add the first call. And in here, eager singleton.get instance, and add this, and again, second call. And then let's just close our app. Close app. So in this example, we should be able to see the actual load-in time, how much time it would take for the application to load, how much time it would take the application to get the first call and the second call here before closing the app. So when running this, let's see, starting the app takes some time, first call takes 1 second, second call takes 1 second, and the application closed. Let's try to make some minor changes. For the get instance, I am going to make it less time, take less time, and give more time to the actual initialization here. And let's do the same for the thread safe. So for the initialization, it's 3 times, and for the return, it should be 1 time. So to be able to perform this, I'm going to make this 2, so that it's 2 plus 1 is 3. Alright. I'm not using this method, so it's fine. I can keep it that way. So when I run my application, again, you can see that the start time is taking some time, but the first call and second call are pretty quick. That's for the eager loading because it impacts the startup of the application. Now let's go perform the same operations using the thread safe singleton. So let's call these, this, and this, and call the get instance optimized. So we're loading the configuration, getting the instance, first call, second call, and then closing the app. Let's run this. Let's try to focus here on the results. So the start time is quick. but the first call takes some time. The second call takes less time. It takes 1 second. Let's run it again to see the results. Application start time is quick, but the first call takes some time. Second call, much less time because it has to wait only 1 second. So that's it for this video. I hope you got to understand the differences between the lazy initialization and the eager initialization. What are the advantages and disadvantages? If you have any comments, feel free to add them in the comments below. Don't forget to like and subscribe, and I'll catch you in the next one.